Hi, this is Dave Archer. In this video, we'll review smartphone attachment and calibration for the VeloAngle Enthusiast. As this model simply replaces the VeloAngle Pro's integrated inclinometer with the user's own smartphone, all operational instruction will be contained in the VeloAngle Pro video. Because the user will influence the accuracy of the tool, and many users may not have experience with calibration, we will cover these aspects in some depth. Shipped with the Enthusiast model is a starter quantity of Command adhesive strips. The pull to remove design is handy, and the adhesion is adequate but not excessive. What is excessive is the price you can pay for this proprietary convenience. Price shopping the 60-piece poster strip package shown here can lower the price significantly. You may note that one side of the strips is described as being for the wall side. The adhesive looks and behaves as if it's the same on both sides. It's likely this note allows 3M to only print the pull arrow on one side, thereby reducing cost. 3 widely spaced strips has proven sufficient in our experience. Apply to the phone rather than VeloAngle to ensure that projections on the phone are avoided. Significant protrusions, such as this camera lens, is higher than the thickness of the command tape and would prevent proper alignment. Typical double-sided adhesives, such as this, come in a wide range of thickness and will work as well. Test adhesion on a small area first. As it's more likely to be greater than needed rather than less, be cautious of leaving a phone attached for an extended period of time. One adhesive that can't be used is this tacky adhesive commonly referred to as snot glue. Since boogers don't have constant thickness, they won't provide consistent results. Whatever the adhesive used, check that both surfaces are clean before application and press the phone down firmly. Position the phone so that it doesn't extend beyond VeloAngle's edges, as those edges will greatly influence calibration quality. Centering left to right on the screw holes used for the Pro inclinometer is a good reference location. If command strips are used, make certain the pull tabs don't extend past the top edge to ensure that they don't get pinched during calibration. We are now ready to discuss angle measurement. Broadly speaking, measurement accuracy can be broken into these 3 factors. Because in this case we are interested in digital measurement, I use the word sensor to describe the measuring device's behavior. But linear behavior over a desired range also describes how a quality ruler needs consistently marked graduations. Calibration is almost always needed for digital devices because signal levels need to be set, while mechanical assemblies often require some kind of adjustment. For example, adjusting a rear derailleur could be described as calibrating it. In the case of VeloAngle's Enthusiast model, we ship a calibrated length scale with no angle measurement capability. Not only does the angle sensor need to be attached and calibrated, but the sensor first needs to be selected and loaded. To put these factors in better perspective, let's assume the product in question was a simple bathroom scale. The sensor in the case of a digital scale is a load cell that outputs a voltage increasing with load. Mechanical scales use a spring that compresses, extends, or deflects depending on design. While the calibration methods would be dramatically different in either case, in both cases the 0 point in range needs to be adjusted. Once the calibration method is determined, it needs to be carried out as intended. In this case, to ensure the conditions that are listed here on the slide. So who or what largely controls each of these parameters? First, the sensors are obviously contained in the smartphone. The user will likely be interested in whether there are differences between models and manufacturers. This isn't an area in which we are at all expert, although based on testing 4 different models from 2 manufacturers in which no differences could be detected, it seems likely that phone selection will not have a significant influence on results. How the chosen application uses the phone's sensors will have a noticeable impact on results because calibration procedures vary greatly. More on this later. Finally, it's in the user's interest to be a diligent technician to get the most out of their tool. After experimenting with several Android apps, the one we recommend and will be highlighted is Calmatic's multi-clinometer, available on Google Play. We have not studied iOS applications. However, enthusiast customers with iPhones can use the information provided in this video to make more informed decisions in selecting their app. For convenience, PDFs of the calibration procedure and button functions can be found on the downloads page at VeloAngle.com. One of the reasons we recommend the multi-clinometer app is the convenience of not requiring perfectly plumb and level surfaces for calibration reference. It's important that you maintain parallel edges during the first 4 calibration steps. Calibrating with the phone on VeloAngle is helpful in this regard, in that the long rectangular shape makes alignment easier. After experimentation and consulting with multi-clinometer's developer, we recommend that you use the pitch roll display option. I think you'll find the interface is most informative and intuitive for this application. Also, it nearly eliminates pitch errors when the measurement plane is not perfectly vertical. In other words, the bike is leaning against a wall. As noted on the slide, the terminology of pitch and roll, adapted from flying, would probably translate best to tilt and angle respectively for our use. Immediately after the phone is calibrated, when attached to VeloAngle, it can be used as is. Once the phone is removed, the zero plane must be re-established. The phone does not need to be recalibrated. Reattach the phone following the same guidelines covered previously, so that it appears to be aligned. Touch the nibs to the surface the wheels are resting on. If the surface is uneven, the nibs should be extended so they touch immediately adjacent to the wheel's contact points. We want to set angle without altering the calibration in the vertical plane. From experimentation, coming within a ½ degree of vertical when resetting zero doesn't alter the measurement when the bike is within 5 degrees of vertical, which is more than enough to keep it against a wall. This clip shows that angle measurement is not affected by tilt when Alt-0 is set as recommended. This performance wasn't seen in other apps we tested. For comparison, this clip was taken with the same calibration, but after setting the Alt-0 at 2 degrees from vertical rather than the recommended ½ degree max. You see that some error is introduced. Next, we'll switch between the pitch roll and 2-axis bubble level displays in the same setup as the last clip to show the tilt error, and that the second axis, intended for when the phone is laid on a horizontal surface, tends to provide more confusion than additional information. This clip shows the same calibration with the recommended Alt-0 procedure undergoing a similar test to that used for calibration of the VeloAngle Pro model. As you can see, with some care you can feel confident in your measurements. Even if you don't have a known plumb and level surface, a good check is to rotate the tool 180 degrees in each axis to see how well the readings repeat. If you have any questions or comments, please feel free to leave them in the comments section below or contact us at VeloAngle.com.